Hello, Mason Graham for Architecture 251 with a little experiment on surface temperatures and microclimates. All right, so the agenda, we're going to do a little introduction, establish a base, temperature on different surfaces wide, and final takeaways. So our introduction, we're using snow slides because it's been snowing and I got to go snowboarding the other day, so it's pretty exciting. We're going to examine how surface temperatures are going to change with the introduction of insulation and external heating sources versus, external forces such as, 34 degrees outside. I'm going to use the CMU walls that make up the foundation walls of my basement, and I'll compare it to the heated and insulated walls within my office. All right, so the base. The office is heated a heated office is using forced air to a temp of about 68 degrees. This will be confirmed by a picture of a digital thermometer. This will be the base inside. The base outside temps will be confirmed by the same thermometer outside. So standard basement, you got CMU wall foundations, 10 millimeter vapor barriers, 1-inch R5 insulation board, 2x4 16 on center wall framing with bracing, 3.5-inch R15 insulation, 1/2-inch drywall, 1 coat of primer, 2 coats of paint. Normal thing. So here we go. If you look into the top left of the slide, we have our two bases. We have a 68.1 inside ambient temperature and a 34.8 outside ambient temperature. So, pretty spot on with the inside ambient based upon the zone and the heating that the thermostat is set at, right? Next, we're going to see on the far right, this is the inside interior of the office. So this is the wall that's facing the inside towards the house. It is 66.7. So we have a little bit of loss there, but nothing bad. It is holding tight. The insulation is doing its job. All right. So then we go down to the bottom left. We have the exterior facade of the basement foundation, 36.3. Not quite ambient room temperature, but not far off. Then we go to a microclimate that is created by factors. And those factors are the thermal energy retention ability of a metal door on a metal frame that is braced to the CMU foundation wall. It's 62.4. So definitely unable to retain, energy on the inside of the door, even though it is heated. So that will create a microclimate there. Then the next is the foot of the window, which is 59.1, which is alarming because those are pretty bad windows, pretty drafty. But as you can see that this is wood on top of the 2x4 wall and also the CMU wall. So even with a 1-inch piece of insulation foam between them, they are still not retaining that thermal energy, and that's due to the inefficiency of the windows. The why, we kind of talked about it there a little bit. My drafty windows are killing me. The room itself is doing pretty well, but the inefficiency of a couple things have now created microclimates within this room, even though there are heat and forced air coming into this room. Conclusion. The importance of material being selected when constructing how efficient a building will be is crucial. So even though this room is up to code according to the IBC 2018 for South Middleton, even though this room is code compliant, it is not the most efficient build. As you can see, this room could be drastically better, hence the windows, and my office would be cozier. How thermal energy is retained and released is crucial to building a sustainable building. This kind of gives an insight as long what the professor has been getting at is, the materials that you use in how the building is constructed or how a room is constructed to maximize those efficiencies of the material selected is extremely important and can help make a more sustainable and cozier living environment. So thank you. That is all. I appreciate it.